In this video we are going to look at the force of gravity. Now we know that if there is something on the surface of Earth, or even maybe 10, 20, 100, 1000 kilometers away from the Earth, that object feels or experiences some force towards the Earth. Now this kind of force is known as the gravitational force. In general, any two masses separated by a distance will experience a force of attraction, and this force is called gravitational force. So what is it? It's between two masses. Now gravitational force is one of the fundamental forces of nature. There are four fundamental forces, and one of them is gravitational force. If we look at electrostatic force, which is the force between two charges, we know that that force can be attractive and can be repulsive. So if you got two positive charges, two protons, they will repel each other. And if you got opposite charges, did I say it wrong? Okay, if you got two opposite charges, then they will attract each other, like electron and proton, they will attract each other. But if you got two similar charges, like two protons, they will repel each other. So electrostatic force can be attractive as well as repulsive, but gravitational force is only attractive in nature. Only attractive. There is no repulsive force between two masses. Another comparison, if I want to do with electrostatic force, then I would say gravitational force is comparatively weak. Now we have a formula for gravitational force as well, and the formula is F is equals to G times M1 times M2 divided by D squared, where G is universal gravitational constant, and it has a value of 6.67 times 10 to the power minus 11. Let me write this again, this part. Newton meter square kilogram square. And what is M1? M1 is your first mass of the first object. I think that's how I would write it. Mass of first object. M2 is equals to mass of second object, and D is equals to the distance between them. We need to be careful here. The unit of mass is always in kilogram, and the unit of distance is D. So this formula gives you force between two masses, where this one is your M1, this is your M2, and the distance between their center of gravity is D. And this force will be repulsive. So this M1 will experience a force of I'll correct this. This force will be attractive in nature. So this M1 will experience a force towards M2, and M2 will experience a force towards M1. Let's look at some example, and the first example that we are going to look at is force between two persons. So suppose there are two persons, like one man here, 90 kg is the mass, another man here, 90 kg. Between these two persons, the distance is they're separated by 1 meter. So we plug in the values in this formula there. F is equals to G is this in place of G, or let me just write the formula as well. That gives you, in place of G, I will write 6.67 10 to the power minus 11. That's 90. Second person is 90, and distance is 1 square. And if we calculate this formula, will come out as this force. Now this force is in Newton, and we can see that it's a very weak force. So if we try to experience this force, we will not be able to experience this force. It's because it's quite weak. But the same force gets bigger when the masses are bigger. So on planetary level, and when the mass of the when we are thinking about force between planets and stars, then this force becomes huge. So let us find out the force between Earth and the Moon. So let me do it here. So this is my Earth. We know its mass as well. So the mass is 5.97 minus 10 to the power 24 kilogram. And this is my Moon here. Mass of the Moon is 7.35 10 to the power 22 kilogram. And the distance here between here to here, this is the orbital radius. Like Moon is going like this around Earth all the time. Okay, so that this distance is the orbital radius. And this orbital radius is 3.48 times 10 to the power 8 meters. Yeah, but because it's the orbital radius changes, so you normally look at the mean orbital radius. So this is basically I'll say this is the mean orbital radius. So force of gravitation between Earth and Moon will be, this is mass of Earth, this is mass of Moon, and this is orbital radius here. So 6.67 times 10 to the minus 11, 5.97 10 to the power 24, and 7.35 times 10 to the power 22. That's the mass of Earth, that's the mass of Moon, and divided by d square. So 3.48 times 10 to the power 8 square. Now a word of caution here: when you are entering this expression in calculator, we need to be really careful to put these brackets, right, and do the square here. If you plug this in calculator, you will come up with a force of 2.417 times 10 to the power 20 Newton. So now we can see that this force is huge here. It's a huge amount of force, only because we are now finding force between two huge bodies. All right, let's look at another example. Suppose we got this is our Earth, and now let it come out nearly well. I mean, this is the Earth, and this is the center, and we have a person here, say little bit, I mean, away from Earth, or obviously you can call it on the surface of the Earth, but just look, for example, that person is here. So now we can calculate the force between Earth and this person. This person's m is equals to 90 kilogram, and Earth we already know is 5.97 times 10 to the power 24. So this Earth and this person, they will attract each other. So in other words, this person will experience a pull towards Earth, and we are familiar with this thing. We know that everything gets pulled towards Earth. So let us find the force. Let's find this force. So this force F is equals to, I will straight away plug in the values there, times mass of Earth is 5.97 times 10 to the power 24, and mass of the person is 90, and the distance here is obviously it is equals to the radius of the Earth. So radius of the earth is equals to, I can write the value here, I have it readily available. Radius of the earth is equals to 6.371 times 10 to the power 6 meters. So this is my 6.371 times 10 to the power 6. Now here we need to be careful. I'll spend some more time here. The distance, when we, in this formula of gravitational force, the distance that we are talking about is distance between the center of gravities. So if you got, like we looked in the case of Earth and Moon as well, we took the distance as the distance between the center of gravity of Earth and the center of gravity of Moon. So this person, if it is on the surface of the Earth, the distance between Earth and Moon is not 0. We need to find the distance. We need to take into account the distance from the center of the Earth, which is center of the Earth here, and the person. So the distance is RE here, RE, which is the radius of the Earth. And if we calculate this, we will come up with a force of these many newtons. Right? So a 90 kilogram person will experience a pull of 882.93 newtons. Now we know that anything that experiences a force will undergo an acceleration. The formula that we normally consider is this, and this formula means if an object is experiencing a force, it will undergo acceleration. So wherever there is a force, there will be acceleration. So I'm looking at this man here. The mass is 90 kilogram. If I look at this person, it is experiencing a force of 882.93 towards the center of the Earth. So obviously there must be some acceleration as well of this person. If you think a little bit, this is the acceleration. What acceleration is this? This is the acceleration because of the gravity of the Earth. Acceleration because of gravity of Earth. And how do we find this? Straightforward. You just use this formula. So this acceleration because of gravity, so I'll say G is equals to F divided by M. So force is 882.93 and the object's mass is 90, and you come up with 91.81 meter per second square. And we are familiar with this acceleration. I mean, we already know that acceleration because of gravity on the surface of Earth is 9.81 meter per second square, and we call it 9.81 meter per second square. We can find a general formula for this acceleration as well on the surface of any planet. So suppose, come back to the same situation here. This is my Earth, the radius is R, and the person is on the surface of the Earth, and the mass is M here, and this is M. This is the mass of the planet. So it could be Earth or Mars or Venus or any planet for that matter. So this is the M here. This M small mass will experience some force. And what force would that be? That would be G M divided by R square. Now this is the, and I'll write again, this is the force on M. So what is the acceleration of force? Acceleration of M? Acceleration of M is equals to F divided by M. So you got G M R square, that's divided by M, and that gives you, I'll give you this acceleration because of gravity, that's the symbol here, and this will be Gm over R square. Now very important formula. Using this you can find the acceleration of a gravitational acceleration of any planet. So, and we know this M is the mass of that planet and R is the radius of that planet. very important, and you can use it to find acceleration of any planet. Other thing to keep in mind is this basically gives you acceleration at the surface. What if you got this is the planet and object is at a height. This is h here and this is your m. So this is r, and in this particular case, I mean, if we just find the force first, the force will be F is equals to force on this small m will be g m divided by d square, and d in this particular case is r plus h square. So gravitational acceleration is basically the acceleration of this object because of the gravity of this bigger object. So again, same thing we'll do here, just like we did found the acceleration here. The acceleration of m is equals to F divided by m, and g m divided by r plus h whole square. You dividing by m, and you come out with g m divided by r plus h square. So that, in a way, this could be the general formula that you would use.